Yeah, I can go back and like fill in because I know we're gonna, some of you guys are gonna take off here, and I can go back and fill in this one. I did start recording right now. Sorry, this is what it looks like, everyone, which isn't too bad. Yeah, it's like just model it as it is, mostly as modeling, and then I've started to just throw my normal drafting dimensions on that I'm used to doing. So I haven't done anything out of the normal here, other than I've kind of analyzed it. I like these dimensions better. That's the only thing I've really changed here. And that's the last. I can't think if I'm missing any. I mean, I can now check my cheat sheet to see if there's any dimensions. Yeah, a depth. I'm missing that, of course. Of course I am. Yeah, except for I don't love this. Oh, like, yeah. Oh, yeah, yeah. It is on. It was drawn so that it did. So I was easy. This was my front view drawn on a profile. Yeah. Yes, I did a revolve for sure. But I don't love the dimension for that depth either because it's kind of it's pulled from a surface down, and it's a surface, it's a round surface for one, so it's just like one little point of that round. If I can really hold a dimensioning tool at 12 o'clock and pull it down. I don't love it, but I'm going to control the center axis as a datum, so I feel like a better dimension for that depth would be from here to here. It does make way more sense. Yeah, just, I don't know. I think I had that quote was like, when in doubt, center line out. Definitely center line dimensions, especially on round.
Poor guy, calipers and the calipers.
Trying to hold his tape or whatever it is perfectly to measure eighth of an inch down or something. Yeah, I like this better. I do want the 4 decimal place standard that was on the other drawing. So I'm going to change all my dimensions to be, so I just change one here to 4 decimal places. And the tolerance, I will want it to be 4 decimal places as well in an inch units. So say, yep, even though I'm not going to apply a tolerance to all these. At 4 decimal places, it's really the same tolerance as 3. It's just that I do carry 4 decimal places in the display, but it really doesn't make a finer tolerance necessarily for the extra decimal place, in case you haven't ever looked at that. But they're actually the same tolerance. In a way, actually, I can't. I just have the option to have a fourth decimal place show up there if the dimension was modeled that way. So let's see. So then I'm just going to copy those properties, right? I think I just hover over it, copy properties, and let's go to town here. I'm going to have to replace that one to unfortunately, that will take I like the diameters stay, but it kind of messes up any of your local notes. I'm surprised the chamfer, I think I just left. It's just a 2 decimal place chamfer. So I think it's maybe a non-critical, just knock the sharp edge off and then I will make this one a reference dimension though. Okay. So I think there is a good start. Now let's do GD&T. So we've decided that we want, like, to me, when I look at what's going on here, they're really like most of all the GD&T really is associated with uh the form of this particular little extension, the smaller diameter extension here from this shaft. So this seems to be what we're controlling mostly. Definitely we are controlling, like we've established that the datum we want to use is, and there really isn't any datum control here. It's just that the datum is the axis of center line. So they've applied it right here. Then the other datum we want is kind of the shoulder surface of that, where those two diameters change. This is definitely a surface datum and an axis datum. So I'll apply my two datums that way. I'll keep those same two, and maybe that'll keep me from having to add a third datum by changing my dimensional where I'm pulling from. So I will say datum. Datum A is this one on the axis here. So I think I can just select, oh yeah, I don't have that dimension. It's over here. So I got to put it over here. Just by the way, I pulled it in between the two views. I like that better too. So that's one other change I've made. And it doesn't like that, does it? Yeah, let's see. I think if I just select this, yes, it will let me place it and then I'll slide it over. That'll be datum A, only I'll turn it so it's just straight up and down. And that would be datum A surface, which would be that top surface there if I didn't change this. That's also a broken surface on the top, so that gets a little more complicated as a datum necessarily, that I have this break in that continuity between that datum. So that's not where I want it. I'm going to actually say it's the axis by sliding this thing over and aligning up with the dimension. So now that's become not a surface, but it's become an axis. Datum A through axis, that thing right there. Great. Um, Datum B shoulders. Let's do that one too. Datum B shoulder right there. I'll change that to B. And I think, and then I'll just leave it like that. But it wouldn't have been wrong to add a third one and pull all your dimensions from the end. So I think that's a valid way. But now I've made it so all my dimensions are kind of pulling from, in some ways, pulling from the axis or from the datums. And then what I would need to identify maybe here is definitely what this is controlling. So I maybe like this one, only I think I'm just going to increase maybe how much. Like 5 thousandths is better than 2 thousandths, but I think I'm going to take it all the way up to 10 thousandths that I'm going to give them for cylinder. This is a cylindrical form tolerance. It's not a datum, it's just form control over that surface, right? So we need to maintain the cylindrical nature of this little protrusion out. And I'm going to say within 10 thousandths. So this is, and I'm going to point to that surface. They've even additionally applied a finish symbol, and which is that little check mark with a number. This is like they want the machinist to pay attention to how fine or coarse the finish of that particular part is. Maybe it slides into a bearing or something. I see a shaft like that with that little protrusion like that, and I'm thinking, let's slide a bearing over that thing to support that shaft, or some type of a probably allows it to turn. Um, I can't remember what chapter surface finishes are, but in your book, I could probably look real quick. There is in our book, it has a great like little chart of general surface finishes. Let me just look. I'm just stand by for just a minute. So I'll apply those while I'm in there doing at least that geometric control. It's like I'm going to control its cylindrical nature of it, and I'm going to control the finish of it, so it's like not coarse or fine, and or not too fine or not too coarse. So surface finish, SUR. I know my alphabet. I just can't remember which chapter surface finishes were covered in. This is important to me. I could Google search it faster. Just that you have to kind of know, like, what does 63 mean? I don't know. Well, I kind of do know, but surface, SUR, surface roughness, surface texture. I think this is in three. It looks like it's in page 330 something, 334. What chapter is that? 595. Yeah, is this 595 in our textbook? Or you said, let me look up what you're looking at here. 595 on working drawings chapter. I don't see it there. I'm not. Oh, there is surface finish of shaft. Oh yeah, that does say that it does show that these numbers are in micro inches or in micrometers, I think on a metric print. So we're talking micro inches because we're on an inch template. There's another chart though. Let me look at the 330s, 334 or something. This is in the dimensioning and talk. Yeah, it is. It is, I think yeah, it's page 333 and 334. Because when we get into this surface finish box, you'll see some of this stuff start to show up. And I don't know if there it was any quizzing on this at all when we did chapter 10, but 333 shows that there are some like how to finish. Like the interesting thing is they use kind of like a perpendicular sign, kind of an equal or parallel looking sign, an X, a C, an M, and an R. I'm on page 333. It just shows, yeah, it shows the machinist like how they want to, maybe the direction of the milling machine or whatever it is, it's going to, whatever tooling they have in their machine to get the surface finish correct. With some of this, like just kind of variables they look that you would apply to your finish symbol. You can kind of tell the machinist how they want. That would be something I would be dangerous to go into because the machinist knows how to use their machine way better than I do. And if I'm going to tell them, I need you to use a circular relative to center finish, they'd be like, you're an idiot. If I did it wrong, anyway. If I did it right, they'd be like, man, you're really smart. You actually know how to communicate to us. I would just be, yeah. So using the symbol to tell them how to finish, you better almost be a machinist. Or have a conversation with one to tell them, how do you surface finish that? I'll add that to my drawing. Because on the next page over is the numbers in micrometers and micro inches. So on metric ones, there'll be different numbers that show up. But what I love is this. This would be something like if I was in a drafting industry where surface finishes were something we always detailed, I would want to copy paste that little thing or have some note from Google to know like what are the different numbers in surface finish. So 63 is what's called out on this. And on page 334, it says that's a good machine finish. Sharp tools, high speeds, extra fine feeds and cuts. So it's a good, it's not, it's above medium, you know. So the lower the number, the finer the finish, the higher the number, the rougher the finish. With a medium, and I think of when I see medium, I think of that's kind of like general purpose. If I'm not calling out anything, it's going to be maybe a surface finish of 125 micro inches of surface finish roughness. This is calling for a little bit beyond that. So, and it could be that the bearing, could be that if I'm slipping a bearing on this, maybe the bearing supplier is telling me what they need the surface finish to be in order to like correctly seat their bearing on my shaft. So that can be something that you have to pay attention to based off manufacturing equipment, unless you're the bearing manufacturer or whatever. But anyway, 63 is a good machine finish. High grades 32, 16, extremely fine feeds and cuts. So it just takes time. The finer machine finish I call out, the machinist maybe has to step down tooling in order to like get that. It's almost like sanding something, at ultra fine sandpaper. Um, so anyway, I thought that was interesting because this particular drawing, I don't remember doing it on any other drawings yet. So I wanted to kind of beat that to death. I think I've sufficiently done that. So that means that we've got a couple geometric, like we're trying to control, especially this a little bit more than just general purpose. So we want to control its cylindricity, I don't know. Yeah, I think that's right. Cylindricity, the cylindrical nature of that feature. And so it's just going to be a feature symbol. And I think I can just use its leader line capability here, right? I'm just going to point to it and say, hey, I'm going to control this, double click it. I don't want any presets, so I'm going to start with a new fresh one. I'm not controlling position of that. I'm controlling form. And it's not even a datum. This surface really isn't. It's just that I want to control the form. And so I say, oh, it's the cylindrical. And I'm going to say instead of 5 thousandths, I'm going to give the machinist a little bit more than that in original drawing. We decided that 10 thousandths would be a more realistic finish on this. So that means I'm just holding the form of that from really the axis datum A there going through it. I'm just probably going to evaluate that as I run my inspection tool across here, that the cylindrical nature of it doesn't deviate beyond 10 thousandths, at least in this area. And this area to me is less of a control, obviously. I'm not worried about this. It can kind of run as general size. I think I'm controlling the surface finish of it, but that's about it. So I'm going to say okay on this. It's just form control on that feature. And I need a surface finish control though. So that's the surface finish right by welding. Surface finish. I think this is kind of goofy because I do want to place it not on the object. It's like any dimensioning tool. I don't want it to be I want it to but I think I can just place it like here, or I could place it here. These are both the same surfaces really. I'm just going to place it, and then I think if I have no presets, it just has the basic one, if I'm going to actually do some removal of material required or no removal of materials prohibited. I think right here is where those that's just our normal, okay, there are normal symbol library. I was thinking there was a symbol library on here for maybe it's this one. Yeah, this one gets into that stuff where you're controlling the tooling that the machinist is using to finish this off, and that this one I would be leery of wanting to apply this without better understanding. So really, I'm just looking to enter this one here, if I hover over it, does it tell me the roughness average max? Yes. What is it? Oh yeah, I haven't. I just I would say don't worry about it if it didn't pop down like that because I think you can just grip it like when you're done here.
Click one, and then drag down the direction.
It just jumps that way.
Just move your mouse that direction, and then I use right click and drag to the right.
Yeah, because what I was saying is even if I just place it here,
But if you bumped it, like then it will.
yeah, this is movable, right? Like you can even turn it into because these can be leader line driven as well. So if I can't get into the direct surface, kind of like a datum in some ways, I can actually pull this away and have a leader line apply to it. So I know it gets a little busy, and then I can double click in here to get back into that menu. And all I'm really adding is that surface finish. I feel like this is real just surface finish 101. I would probably leave them unless and the machinist would probably say, oh, I'll put it at 125 micro inches of finish. Here I'm just saying the one thing that I might do is express a little bit finer control here. But I would probably only do that if my bearing, whatever I was putting on this, if it had something, if I had an indicator to call that out. But I think that's what we're doing. We're just controlling that surface. We're even controlling this one, so I can put the same one over to this surface here. Oh, I probably snapped it to the center line, which is okay. And then I didn't let it apply. It's 63, but 63 micro inches. I think those are the only two surface controls. Those are really our only two surfaces. Not really. We have some flat surfaces, but okay, now we need to do what now let's analyze what we really are controlling other than we've got some cylindricity control. So what else now let's look at what they're saying. I think this one makes sense to me. Other than I'm going to increase the tolerance on it, I think a little bit. So these 2000s is two. I'm going to go to 10,000s as well. So what it's saying is, okay, I'm controlling this size, which is 0.625. And it looks like the controls I'm saying is it needs to be perpendicular to datum B, and I'm going to increase this to 10,000s. So I need that this, and really that is, if I think about this, yeah, I'm saying that it can be out of perpendicularity only up to 2000s right here. Should that be a diameter? I don't think so. Is that? I would question whether that should be a diameter or if it's just kind of a. Do the diameter make sense there? Hmm. It would make sense to me on this on this the concentric nature, asking that I would be concentric to datum A at 2000s, which I might increase to 10,000s. Or at least match, yeah, match maybe what my cylindrical. What I would worry about is if I have like conflicting tolerances here, like I'm like maybe holding a tighter tolerance than the cylindrical nature that I'm holding. These kind of do work together in some ways. So that's one reason why I don't love these tolerances. Maybe. But and then I question whether or not I need a diameter here, because really I'm saying it's a perpendicular, and a perpendicular would be more of an angular. Hmm.
Well, isn't cylindricity controlling like how circular it is along the length?
Along the length of
Whereas
this.
this concentric is just how centered on that axis it is.
Yeah.
And then that perpendicularity, would that be describing the face? The face, how perpendicular it is to datum B?
Datum B. It could be. But would it be diameter though? It wouldn't be diameter, no? It's I don't know. This one has me questioning that little so I'll put it on there, but I'm going to question that, and I'm going to have to do some little research on like perpendicular controls and how they're yeah. And I wonder if I even need one or if it's just like I'm gonna yeah, I'm gonna research this. I'll put it on right now, but I'm gonna do a little research on that one. So, because I even question why this isn't basic then right here. Like I feel like I'm controlling, I guess I'm not controlling overall size necessarily. I'm just controlling how perpendicular this little tendon is here and then how concentric it is. So maybe it doesn't really impact the size. And so we haven't added a basic size we're just, yeah, it's kind of interesting to me. And it makes me question a little bit. I haven't done a lot of like deep thinking on it. Deep thinking. I need to meditate on this thing a little bit here. So that's what GD&T makes me do is like really try to overthink this because it'd just be really simple to make a stupid statement, right? Um, I will apply it as it is. I think it's just a two road, so I'll apply it as it is and I'll think about it. But it's the last thing we need to do. And there really are no basic dimensions associated with this then, actually, which is kind of interesting as well. So it's going to be from datum A, which is on this same this one here. Yeah, so I'll add my datum here. Let's see what will work. Sorry, add my feature symbol. but I don't know if I have to be perfectly perpendicular either. That one was kind of in CAD, you build them a little bit different. It's actually easier to do that. But what I have is we're saying perpendicular. I'm questioning, I like the 10,000s. That's actually what I do want to use that 10,000s. And I guess I will say diameter here, which is right here, right? Diameter. I'm just going to question that later. It's no maximum material condition applied, but just that it's perpendicular to datum B is what I'm trying to control here. It's not too, I think I think it is read as preference though. So if I stack that one above the other one, I do think I would consider its perpendicular nature first as kind of maybe its primary control, and then secondary is going to be how concentric it is to A. And really, you're going to have to check to both. And so I don't, even having a precedence order is not, I wouldn't say either one really takes precedence over the other. Just they both have to be evaluated how perpendicular it is to surface B or datum B and how concentric it is to datum A. I feel like they're both going to be evaluated with equal kind of control. What usually when I'm actually expressing multiple datums, that one does matter. So on the last drawing where we did A, B, and C, that is kind of definitely dictating an order of because you could switch those around as well. It doesn't have to be A, B, C like it did. It could be that I want to say actually control A as the primary, C as the secondary, and B as the tertiary. So really think of it as what you're saying is how is the part going to be put in a datum feature simulator or some type of a inspection piece of equipment? What are you going to consider as the primary, secondary, and tertiary like datums in that feature simulator? That's I think what drives that. And so there definitely is, and they talk about that in those videos from last week. He says like it does matter. The order is totally up to you, but it will affect how the part is inspected because they will read it as when you have multiple datums in a feature control frame for one particular type of control, they will do it in the order of those datums. Whereas this one, I think they kind of are independent of each other. It's just almost like we're bundling them together and saying, hey, since I'm calling out the perpendicular nature, then this one is also easy to call out the concentric nature to makes more sense here, a diameter of, and I'll say it's the same 0.010. I probably should increase this to match I probably should add another zero here as the tolerance. This is another thing that I can look up is generally with a plus minus tolerance, we would carry the same decimal place as our dimension. I could argue that maybe GD&T can break that rule, and I could say that I'm actually only holding to 3 decimal places. I'll look that up too. So this is another question I have. My gut would tell me I think I need to carry the same decimal places as the rest of the drawing because it is kind of a tolerance, and for tolerances we carry the same decimal places as their dimensions. So I would kind of like do this first, and then I would have to do some research and be like, can I actually change that? And then it's just datum A that we're holding that to concentric nature to. And so I've just increased, and then we've got this ugly thing that I see if I can position it any different. Yeah, that works pretty good. Yeah. I can pull it up a little bit more. I think you could even point to that surface. I don't think I have to point. Like I would even question how can I move my leader line to point to different things? It makes a big difference, but yeah, I would think that I probably could move that to just point to the surface. But this is really the end of this drawing, right? I think so. With a little bit of touch up there. What's that? Yeah, if you think about it, I'm not really controlling any like dimensional locations with GD&T. I'm more controlling form than anything. What does perpendicular fall under? Which grouping? What is it? It's position. Is that right? No, no, no. Position falls under location. And let's see here. Perpendicular falls under orientation. So if you remember, like your wall chart, GD, yeah, definitely know how to bundle these under like straightness, flatness, circularity, cylindricity, or form controls. Orientation controls are parallelism, perpendicularity, angularity is orientation. Profile of a line, profile of a surface. I'll never probably even touch one that I worry about that. Or run out. Those to me, I need a little deeper understanding. Location is definitely one that we will use, and that's concentricity and true position. So I guess I am, yeah. In my previous, I didn't have any basic dimensions. Here, yeah, I'd have to sit there and think about it a little bit more. Nothing catches my eye super. The only thing that really did would be this dimension here, and especially because I'm pointing to it, I would almost want to move my leader line to point to the surface, kind of like this control. But I don't know. I'll think about this one a little bit. At this point, I've at least kind of recreated it, and I'll save it, and we'll call that good. There's three more. Yeah, you can turn that in. It makes, but all of these make me have to do a little more homework. So it doesn't end. Do you see how detailed it gets?